Settle in and let the room get a little quieter around you, like the world is gently stepping back. In the distance, there is an ordinary building, an ordinary street, and an air that feels slightly incorrect. You think danger always announces itself with noise, or color, or smoke, but chemistry prefers subtleties. Tonight, you will walk in slow motion with the people who do not touch, do not rush, and do not guess. You will learn why a hazardous materials responder looks calm, not because they are fearless, but because calm buys time. Here in the Sleepless Scientist's late-night universe, the first tool is not strength, it is patience and information. And if you drift off along the way, that is fine too, because the safest kind of science is the kind you only hear from bed. You are standing at the edge of an incident scene that looks almost polite. A door is shut, a curb is painted, a light is buzzing in the same bored way it always does, but the air feels slightly off, like a room where someone spilled something hours ago. You think you would notice danger instantly because your brain loves drama, but chemistry is not dramatic. Chemistry is patient. It sits there, invisible, doing quiet math with your lungs. So the first thing you do is not walk forward. You stop. You take distance like it is a tool you can hold. Because in hazardous materials response, distance is not hesitation. Distance is survival written in plain handwriting. You watch the responders arrive, and you expect speed. You expect running, shouting, heroic gestures. Instead, you get slow steps and soft voices, the kind of movement people use in a museum near something priceless and fragile. This is not because they are calm by personality. It is because the scene punishes curiosity. The scene punishes touch. The scene punishes the human urge to lean in and confirm things. You stand behind tape, behind a cone, behind an invisible line someone decided was far enough. And it is always a decision. Not far enough to feel safe, just far enough to avoid making it worse. The building is ordinary, but ordinary buildings hold extraordinary chemicals. A janitor closet can contain acids. A workshop can contain solvents. A warehouse can contain cylinders of gas under pressure, like metal lungs waiting to exhale. And the street itself can hold residues, drips, and powders that look like nothing. You are used to danger having a shape, a flame, a weapon, a snarling animal. Here, the danger is a property. Volatility, corrosivity, toxicity, reactivity, words that sound like paperwork until they become symptoms. So you start with the first question every responder asks, even if no one says it out loud. What is the material? Where is it? What is it doing right now? And what will it do if you get closer? You look for clues without touching anything. Placards on trucks, labels on doors, a shipping manifest flapping on a clipboard, a faint haze near the ground that might be dust or might be vapor or might be nothing at all. You notice the wind because the wind is a conveyor belt. A gentle breeze can carry a toxic plume in a thin ribbon, almost delicate. It can take something dangerous and lay it across a sidewalk like a scarf. The responders keep their bodies angled, not square to the scene. They keep an exit behind them without making it obvious. They do not stand downhill if a liquid could flow. They do not stand in a low spot if a heavy gas could sink. You learn quickly that the first goal is not rescue, not containment, not cleanup. The first goal is time. Time to identify, time to avoid being the next patient. Because the most embarrassing way to fail at hazardous materials response is to become part of the hazard. You might think you can just hold your breath. You might think you can just step around the puddle, but your body is not sealed. Your eyes are moist. Your skin is porous. Your lungs are a wide open exchange program between you and the world world does not care what you meant to do. Someone in a plain vest is already making the scene smaller, not physically smaller, but conceptually smaller. They are establishing zones: hot zone, warm zone, cold zone. It sounds like a weather report. It is actually a map of consequences. The hot zone is where the unknown lives. The warm zone is where you try to make the unknown stop following you. The cold zone is where people can think clearly without their pulse climbing. And you, for now, stay in the cold zone. You stay back and you watch how often people say the word unknown. Unknown odor, unknown liquid, unknown container, unknown reaction. You learn the first rule of the night. If you do not know what it is, you treat it like it is unfriendly, not evil, not malicious, just indifferent and capable. A chemical does not hate you. It just follows rules you cannot negotiate with. If it dissolves flesh, it will dissolve your flesh with the same calm consistency. If it steals oxygen, it will steal your oxygen without any particular emotion. And this is why you move slowly, because slow movement gives you a chance to notice small wrongness. A metal drum bulging slightly at the lid. A plastic bottle collapsed inward, as if something inside it cooled and pulled a vacuum. A crystalline crust around a cap, like dried sugar, except it is not sugar. A floor that looks wet in a place that should be dry. A faint line running toward a drain. Here is the quiet truth that keeps people alive. Most hazardous scenes do not look cinematic. They look like a spill, a leak, a forgotten container, a tired valve. The drama is not in the appearance. The drama is in what the molecules are doing when no one is watching. And once you notice how much of the risk is invisible, you start to understand why the simplest tool is information. Figuring out what is actually in the air. You step a little closer, still outside the hot zone, and the scene becomes a lesson in invisibility. Some hazards float like ghost smoke, lighter than air, rising and spreading. Some hug the ground, heavy and lazy, sliding into basements and ditches. Some do not travel as gas at all. They ride on dust, a fine powder that looks like ordinary dirt until it reaches your throat and decides to stay there. You have an instinct to sniff, to test the world the way an animal does. But smell is not a safety alarm. Smell is a storyteller. Sometimes it tells the truth. Sometimes it tells you nothing. Carbon monoxide is a famous liar, but it is not alone. There are gases with no odor that can drop you quietly. There are liquids that smell sharp and warning, and yet they are not the worst thing in the room. And there are chemicals that smell familiar, like cleaning products, like a pool, like glue. Familiar does not means safe. Familiar just means you had been near it before and survived. You notice a responder holding a small handheld meter. It looks simple, like a chunky remote control, but it is a kind of extra sense, one humans had to invent, because your lungs will not give you an early warning. Your lungs will take the sample, process it, and file the complaint later. And later can be too late, so the meter goes first. The meter drinks the air in tiny sips. It is not omniscient. It does not detect everything. It just answers a few important questions calmly, in numbers and beeps. Is there a lack of oxygen? Is there something flammable? Is there something broadly toxic? In a way we can measure quickly. You think of vapors as dramatic clouds, swirling and visible. But many vapors are clear. They sit in a room like an invisible layer of risk. They can pool near the floor, waiting for a spark. They can drift out of a doorway in thin sheets that you walk through without noticing. And dust is its own nightmare. Dust is a solid pretending to be air. It floats, it settles. It gets into seams of clothing, into shoelaces, into the soft corners of your eyes. Some dusts are just irritants. Some are toxic. Some are combustible, which means a floating cloud of dust can burn fast, like the air itself caught fire. A chemical does not have to be liquid to spill. A chemical can spill as powder. A chemical can spill as gas. A chemical can spill as tiny, invisible molecules that have no interest in staying put. You watch a small drip from a pipe, slow and steady, like a patient clock. It does not look like much, but small spills spread in ways that feel alive. They creep outward. They seep into cracks. They follow slight slopes you cannot see. They find drains, and drains lead to bigger systems, and bigger systems lead to places you do not control. This is why responders treat even a small leak with respect, because a small leak is often just the part you can see, and the part you cannot see is already negotiating with the building, with the paint, with the concrete, with the air, with the humidity, with your skin, if you offer it the chance. Your body does have warning systems, but they are not precise. Your eyes sting, your throat dries, your skin feels warm or itchy or oddly slick. These are soft warnings with sharp meanings. Sometimes it is just irritation. Sometimes it is nerve damage arriving quietly. Some chemicals cause pain immediately, which is cruel but useful. Some cause little pain at first, which is worse, because pain is information, and the scene rewards information. You think of burns as heat, but chemical burns are not always hot. Some are cold on contact, like a lie. Some are delayed, like a bill that arrives after you forgot you ordered anything. You watch responders point, not touch. They use the back of a gloved hand near surfaces, not for contact, but for heat sensing, and even that is done carefully. They look for dead insects near a vent. They look for plants that have browned along a fence line. They look for condensation in places where the air should be dry. They look for frost on a pipe, because expanding gas can cool metal, and cold metal can be a signature. And they keep returning to the same calm idea. If you do not know, do not guess. Guessing is just speed wearing a disguise. A responder might ask a witness what they saw, but witnesses are unreliable instruments, not because they lie, because they are human. Humans forget details. Humans fill in blanks. Humans say, "I think it was bleach," when it was actually something else that looks similar. And in chemistry, similar-looking substances can behave like entirely different animals. Bleach mixed with ammonia can make chloramine gases, which are wonderfully good at irritating lungs. Bleach mixed with acids can release chlorine gas, which has been used historically to make people regret breathing. The scene does not care that you meant well. The scene only cares about what you combined, so you do not trust your senses for the truth. You trust procedures, and that leads you to the patient-careful ritual of putting on the suit. The suit is waiting like a folded creature on a tarp. It is not glamorous. It is not sleek. It is a crinkling arrangement of plastic, rubber, and seals. The kind of outfit that makes your body sound loud when you move. You think it will feel like armor. It feels more like being wrapped in a warm, noisy bag. And that warmth is not comfort. It is a problem you will meet soon. Before you put anything on, someone checks you. Not your courage, your equipment, your straps, your air supply, your gloves for pinholes, your mask for cracks. Because the suit is not one thing. It is a system. And systems fail at the seams. You start with inner layers, the ones that will stay cleanest. Then boots, heavy and awkward, like you borrowed them from a different species. Then the suit itself, legs first, then torso, then arms. The material is stiff. It resists your movement the way thick winter clothing does, except it does not breathe. A responder helps guide your hands through sleeves, careful not to tear anything. You learn that even putting on the suit is done slowly. Rushing is how you catch a zipper. Rushing is how you miss a folded seal. Rushing is how you create the kind of mistake that stays invisible until you feel something wet where it should never be wet. Now, the gloves. Often layered, sometimes double, sometimes chosen for chemical resistance, sometimes chosen for dexterity, and always chosen as a compromise. Because a glove that resists everything can be too thick to work with tools, and a glove that lets you pick up tiny screws might also let a solvent through. So you choose based on the hazard, based on the mission, and based on what you can actually do with your hands. Then the tape. Tape at wrists, tape at ankles, tape at seams where fabric meets glove, where boot meets suit. The tape is not there to look serious. It is there because leaks love edges. A single loose flap can funnel liquid inward. A single gap can let vapor find skin. Now the mask. Full face, clear visor, straps tightened carefully. It presses your face in a way that is not painful, but not friendly either. Your voice changes behind it. You sound far away, like you are speaking from the bottom of a pool. And then, the breathing apparatus. A tank on your back, a regulator, hoses, a hiss. Breathing becomes mechanical. In through the regulator, out through a valve, with a soft rush each time. The sound is loud inside your head. It is like sharing a small room with a sleeping dragon that only exhales. At first, that sound is unsettling. Then, it becomes steady. Then it becomes comforting in a strange way, because it means the system is working. It means you are not relying on the air around you to be kind. You do a seal check, you cover an opening, you inhale slightly, you feel the mask pull in. You exhale, you feel pressure push out. These tiny sensations are the difference between a controlled entry and an avoidable injury. Someone looks you over like a mechanic inspecting a vehicle. They check your zipper, they check your tape, they check that nothing is twisted, nothing pinched, nothing left open. You realize something quietly humiliating. You cannot suit up alone, not safely. The suit is a reminder that even the most trained responder is still just a mammal in a dangerous world. A mammal needs help. A mammal needs checks. A mammal needs another set of eyes. Now you try a simple task, like picking up a small tool. Your gloves are thick. Your grip is uncertain. The suit makes your arms feel slightly inflated. It is like trying to fold a letter while wearing oven mitts, except the letter might be covered in something that dissolves you. You take a step. The boots are bulky. Your balance is different. Your center of gravity shifts because the tank sits on your back. You have to turn your whole body more than usual because the suit resists twisting. Small movements become deliberate. Deliberate is good. Now you understand why the first enemy is not the chemical. It is your own impatience. It is the ancient urge to solve a problem with your bare hands. Inside this suit, your hands are finally too slow to be stupid. That is the closest thing to wisdom most of us ever get. You shift your shoulders, and the tank shifts with you. The harness creaks, and the suit crinkles like a paper bag trying to be professional. Every sound you make stays trapped near your ears. Your breathing is the loudest thing in your small plastic world. You take another step, and you feel heat begin to collect. Not dramatic heat, not burning, just a slow, steady accumulation, like a room with the windows closed. The suit is good at keeping the outside out. Unfortunately, it is also good at keeping you in. Your skin starts to remember that it is a radiator. Normally, you shed heat into the air without thinking. Warm blood moves to the surface. Sweat evaporates. A little breeze steals the energy away. Here, the breeze is a fantasy. Evaporation is a hobby your sweat can no longer afford. Your sweat appears anyway, loyal and useless. It beads, it slides, it collects in places you would rather not discuss. And instead of cooling you, it just makes you humid. You are becoming a warm terrarium with anxiety inside. Congratulations, you have reinvented the greenhouse effect on a personal scale. This is the part people never picture. They imagine the chemical as the danger and the suit as the solution. But the suit is also a timer, a soft, quiet clock that starts the moment you zip it closed. The clock does not tick with sound. It ticks with physiology. Your heart rate climbs a little because moving is harder now. Your muscles work against stiffness and bulk. Every step asks for more oxygen than it should. Your breathing apparatus delivers clean air, but not for free. You have to pull it in against valves and pressure differences. Not much, just enough that you notice it. A little resistance, repeated, becomes labor. The mask presses your face in a constant, gentle argument. The seal is necessary, but it is not comfortable. A small itch appears on your nose. It is a perfect itch, placed with surgical cruelty. You cannot scratch it. You try to ignore it, which somehow makes it louder. This is your brain, doing what it always does, focusing on the one thing you cannot fix. You swallow, and your throat feels slightly dry. Air from a cylinder can be dry, depending on the system. Dry air turns your mouth into a small desert. A dry mouth makes you want to breathe through your mouth. Mouth breathing makes you feel like you are working harder. You are working harder. A responder outside the suit would call this increased work of breathing. Inside the suit, you call it mildly annoying, and then, later, exhausting. The heat continues to rise, not as a wave, but as a slow tide. Your body tries to dump heat into sweat. Sweat tries to evaporate. The suit politely refuses to let that happen. So your core temperature starts to drift upward. Not enough to alarm you yet, just enough to make you feel slightly impatient. And impatience is dangerous here because impatience makes you rush. If you have ever felt grouchy in a hot car, you already understand the psychology. Heat makes decisions sloppy. Heat makes small problems feel personal. Heat makes you want to hurry just to be done. And the chemical does not care if you are done. The chemical only cares if you make a mistake. You are learning a quiet truth of emergency work. The heroism is mostly scheduling. It is setting a work time and sticking to it. It is agreeing that you will leave the hot zone before you feel like leaving, because by the time you feel like leaving, you might be too slow. The outside team watches your time like a nurse watches a drip. They know that heat stress is not dramatic until it is. At first, you are just warm. Then you are sweating. Then your heart is working too hard for the pace you are moving. Then your thinking gets a little fuzzy at the edges. Then you start making strange choices, like bending down too fast, or standing up too fast, or forgetting a step you have practiced 100 times. Heat exhaustion is a quiet thief. It takes your judgment first. Heat stroke is the version that stops being subtle. That is when your cooling system fails completely and your organs begin to complain as a group. In the worst case, your brain swells, your proteins misbehave, and your cells begin to fall apart. This is why HAZMAT teams treat heat like a chemical hazard, because it is. It is internal, self-generated, and guaranteed. Even in a cool night, under streetlights, the suit keeps your heat like a secret. You look down at your gloves again, and you flex your fingers. The movement feels slow, like you are underwater. Your hands are clumsy, and clumsiness means extra time. Extra time means extra heat. You begin to understand why tasks are broken into short entries. Go in, do one thing, come out. Rest. Hydrate. Try again if you have to. The public wants a single dramatic scene, a brave figure striding into poison. Reality is a series of small errands performed carefully. Your air supply is another clock. Compressed air is wonderful and also finite. It is a bottle of time you carry on your back. The gauge is your conscience. You can see the needle and you can do the math. The faster you breathe, the faster you spend it. Anxiety is expensive. Hard work is expensive. Both at once can drain a cylinder quickly. You learn to move like someone paying for each breath. Slow, steady, economical. A calm pace is not just psychological comfort. It is resource management. Your radio crackles, muffled by your hood and mask. A voice checks in, simple and unexcited. How are you feeling? What is your pressure? What is your status? The questions are not small talk. They are diagnostics. You answer, and your own voice sounds wrong to you. It is flattened, filtered, distant. The microphone picks it up, sends it out into the cooler air. Somewhere outside, someone hears you and decides whether you are still safe. This is another humbling part. In the suit, you are powerful only in the sense that you are protected, but you are also dependent. You cannot see your own zipper behind you. You cannot easily check your own seals. You cannot see the tiny tear that might form at a knee when you kneel. So you are watched. Watched carefully, professionally, without romance. Because romance gets responders hurt. A simple thing happens, and it feels like a turning point. A bead of sweat runs down your temple. It reaches the edge of the mask seal. It cannot go farther. It pools there, trapped, and you can feel it. A tiny warm lake at the boundary between you and the outside world. It is not dangerous, but it is distracting. And distractions are how people miss steps. You remind yourself that everything is a step. Nothing is casual. You lift your foot, place it, and you know exactly where it goes. You do not shuffle. You do not kick debris. You do not create dust if dust is a possibility. You keep your knees slightly bent because balance matters. You keep your hands near your center because a wide gesture can catch something sharp. The suit is durable, but it is not invincible. A nail, a piece of jagged metal, a broken edge of plastic can turn it into a very expensive failure. Not instantly, maybe. Sometimes a puncture is small enough to be unnoticed at first. Vapors can be patient too. They can slip in slowly, molecule by molecule. They can reach your skin in such small doses that you feel only a vague irritation. And then, after the shift, after you have showered, after you have gone home and tried to forget the smell of industrial air, the rash appears, or the headache, or the cough that stays for days. So you move with a kind of reverence, not for the chemical, for the fact that your body is fragile and your protections are temporary. You reach the edge of the hot zone and you stop again. Another check, another glance at wind direction, another quick look at your partner. Because no one enters alone, not because you are afraid of being alone, because mistakes are easier to catch in pairs. You look at your buddy, another sealed figure, visor reflecting streetlight. Their face is visible but distorted, like a person seen through aquarium glass. You cannot read expressions well through plastic, so you rely on posture, on hand signals, on routine. You give a thumbs up, slow and deliberate. They answer the same. Two plastic astronauts preparing to walk into a world that is technically still Earth. You step in, the air feels the same because you are not breathing it. That is a strange psychological trick. The hazard could be thick around you, but your lungs do not complain. That can make you careless if you let it. Your skin, however, still feels the environment through temperature. And now you notice something subtle, a patch of air that feels cooler near the ground. It could be shade, it could be a draft, or it could be gas expanding from a leak, stealing heat as it escapes. A rapid expansion can chill surfaces, sometimes enough to form frost. It is basic thermodynamics, but it feels like a ghost story in the moment. The leak cools the world around it, leaving clues like breath on glass. You move closer to a pipe run along a wall. The metal looks dull in the light, but one joint has a pale rim. a faint crust. That can be residue from a liquid that evaporated and left solids behind. Or it can be corrosion products, metal salts forming where chemistry has been quietly eating. Corrosion is rust, and rust is just a slow chemical fire. Oxidation, electrons being stolen, metals reverting toward ore. It is the universe reminding you that refined metal is a temporary privilege. A responder does not need to know the poetry of it. They need to know what it means for the joint. A weakened joint can fail. A failure can become a release. A release can become an incident with a much larger perimeter. So you measure before you touch. The detector comes up, held carefully. Its pump draws in air. It makes a tiny whirring sound. The screen shows numbers that mean something only because people have been hurt before. Oxygen percentage, flammable range, measured as a fraction of danger. A broad, toxic reading, not a diagnosis, but a warning. This is the quiet compromise of field detection. You rarely get a perfect answer at the scene. You get enough to avoid the worst choices. The meter is like a friend who cannot tell you what is wrong, only that something is wrong. Sometimes the reading is calm, and that calm is suspicious too, because a meter only sees what it is designed to see. Some hazards are invisible even to instruments unless you choose the right tool. And you do not always have the right tool. So you stay cautious even with good numbers. You angle the detector lower, then higher, because gases stratify. A light gas like hydrogen rises like a shy balloon. A heavy gas like propane sinks like spilled milk, and some vapors hover, mixing slowly depending on temperature and turbulence. Air is not a uniform soup. It has layers, currents, pockets. A doorway can breathe in and out as wind changes. A hallway can trap heavier vapors like a gutter traps leaves. You are learning to think in 3 dimensions. Not just where the spill is, but where it could go. Not just the room, but the building. Not just the building, but the drains, the vents, the basements. Industrial spaces are full of hidden pathways. A floor drain looks like a convenience. In a HAZMAT event, it is a highway to somewhere you do not want to contaminate. You look down and you see a thin sheen on the concrete. It reflects light just a little differently, not a puddle. A film. That is often how solvents behave, spreading thin, evaporating at the edges. Evaporation is not disappearance. It is relocation. It is the liquid deciding to become a vapor and explore your breathing zone. And the rate of evaporation depends on volatility, temperature, air movement, surface area. A thin film has enormous surface area compared to a puddle, which means a thin film can fill a space with vapor quickly. This is why a spill that looks small can create a big atmosphere problem. It is not about volume alone. It is about how easily molecules can escape into the air. You crouch carefully, not kneeling yet. Kneeling is expensive in heat and time. You observe first. There is a container nearby, maybe a drum, maybe a portable tank. The label is partially smeared. Of course it is. The universe loves smudged labels. You can make out a few words and a hazard symbol. Enough to narrow the possibilities, not enough to relax. You do not put your face close to read. You do not touch it yet. You treat the container like a sleeping animal, because pressure vessels are not peaceful. They are stored force. A cylinder is a compressed argument with physics. If the valve fails, it can become a missile. If the contents are liquefied gas, it can flash into vapor fast, expanding hundreds of times. That expansion can push oxygen away or create a flammable cloud, or do both at once. The worst part is how normal the container looks. A smooth metal body, a valve, a cap. It is the kind of object people walk past every day. You can buy small cylinders for grills, for tools, for refrigeration work. And yet, in the wrong context, they are hazards with no personality. Your partner signals, pointing toward a corner. You follow the gesture. There is a small pile of absorbent material, maybe from an earlier attempt to control the spill. It is discolored. That discoloration can be a clue. Some chemicals stain, some bleach color away, some react with the absorbent itself. If someone used the wrong absorbent, it can make things worse. Certain oxidizers, for example, can react with organic materials like sawdust or cloth. Oxidizers are chemicals that want electrons. They are not necessarily flammable themselves, but they make other things burn enthusiastically. They are like a friend who shows up at a party with gasoline energy. You keep that in mind as you look at anything that resembles fabric, paper, wood. In hazmat work, you learn to distrust anything that can burn, which is most things humans build with. The radio crackles again. You report what you see, slowly, with plain language. A light sheen on the floor, possible solvent, partial label, possible compressed gas nearby. No visible victims, no obvious smoke, no flame. Outside, the incident commander is building a plan out of these small observations. Plans in hazmat are not heroic narratives. They are decision trees. If this, then that. If oxygen low, then retreat. If flammable readings high, then eliminate ignition sources. Ventilate carefully. Control entry. Ignition sources are everywhere. And that is the bleak joke. A light switch can spark. A motor can spark. Your own clothing can generate static, though the suit is often designed to reduce it. Even so, responders treat flammable atmospheres like a room full of invisible tripwires. You do not create friction if you can help it. You do not drag things. You do not turn devices on and off casually. You live gently for a while. It is strange how gentle you become around danger. Your body wants to tense, to rush, to finish. But the job demands softness, soft hands, soft steps, soft decisions, because a chemical incident is not impressed by human urgency. The suit continues to warm you, and you feel the clock inside you again. A slight heaviness in your shoulders, a mild ache in your neck from supporting the mask and hood. Your breath sounds steady, but you can hear the effort beneath it. You glance at your gauge. The needle has moved, not much, but enough to remind you. Time is being spent. Every second is paid for in compressed air and body temperature. So you and your partner do what experienced teams do. You simplify. You pick one task and you execute it without improvisation. In this case, the task is not dramatic. It is reconnaissance. Confirm the boundaries of the contamination. Confirm whether the source is still releasing. Confirm whether the air is safe enough for further work. That is all. Not cleanup, not heroics. Just knowing. Knowing is containment of a different kind. because the unknown is what makes scenes grow teeth. You move along the edge of the sheen, following it like a map. It thins as it spreads, a faint shine that catches light at certain angles. You notice it leads toward a drain. Of course it does. Liquids love gravity, and gravity loves drains. You stop before the drain and look carefully. Is there discoloration around it? Is there a smell? Not for safety, but for clue gathering. Even through a mask, some odors can penetrate, especially if the mask is not designed for that hazard. But you do not rely on smell. You simply note it if it exists. You see a slight darkening at the drain edge. That could be wetness, or it could be residue. If chemical enters the drain, it can move into plumbing, into sumps, into sewer lines. Some sewer systems are confined spaces with low oxygen and flammable gases already present. Adding a solvent can make a bad place worse. Adding an acid can release toxic gases if it contacts other materials. Adding an oxidizer can create heat. The drain is not a hole. It is a connection to a hidden environment. Your partner gestures. Again, a question. Block it. Not yet. You signal back. Slow and steady. You need authorization and the right materials, because blocking the drain can backfire if water needs somewhere to go. So you mark it, you photograph it, you tell the outside team exactly where the liquid wants to go. You learn to think like the spill, because the spill is already thinking like gravity. Gravity is not intelligent, but it is consistent, which is worse. The incident commander answers in your ear, calm and clipped, and gives you permission for a controlled drain cover. You and your partner do not rush, because rushing turns a simple cover into a splash. A splash is just a spill that achieved career growth. You pull a small kit from your bag, and it feels like unpacking a lunch in a war zone. A drain cover can be a rubber mat, or a magnetic sheet, or a putty that you press into place. The science is dull and beautiful. It is simply stopping flow with a seal. But the situation is never just sealing, because sealing changes where the liquid accumulates. If you block the drain, the liquid might pool. If it pools, it might evaporate faster, and your invisible air problem grows teeth. So you do it like chess. One move, then a pause, then another move. You set a cover near the drain, not touching the sheen yet, and you watch the edge. The sheen creeps, slow and shiny, toward the barrier. You press the cover down, firm, even pressure, and you feel the rubber settle against concrete texture. Now you have changed the map. Now the liquid has to choose a new path. Your partner lays an absorbent sock, a long flexible tube filled with granules, like a lazy sandbag. It is designed to drink a spill without creating a dust storm of its own. Absorbents are not universal, which is a sentence you learn after someone uses the wrong one. Some absorbents are inert, meaning they mostly just hold liquid. Some are reactive, meant for acids or bases, and they can change the chemistry while they soak. In a perfect world, you pick the perfect absorbent. In the real world, you pick what you have, and you pick cautiously. You place the sock gently, because even your hands are a form of weather. In this suit, you are clumsy wind. A sharp movement can aerosolize a liquid, turning it into a mist of tiny droplets. Aerosols are a special kind of betrayal. They are liquid disguised as breath. Your meter stays in your hand because you never stop sampling. The numbers are steady, not comforting, but steady. You sweep the sensor low, then mid-height, then near your face level. You do it the way you would check for a draft in an old house, except the draft might corrode lungs. The air is still, and still air is not neutral. Still air is a storage container. You glance at the pipe again, the crust around the fitting, the hint of a leak. The source might be above, not on the floor. What you see on the ground could be the final chapter of a longer story. You track along the wall, eyes searching for stains, for trails, for any line that suggests direction. You find a damp patch under a valve, and the metal there looks slightly different. Darker, wet. The leak is small, like a secret. The worst leaks often are. Your partner points to the valve handle, and then to you, asking with a gesture, "Shut it." You hesitate, not from fear, but from chemistry. Valves are not magic. A valve can be the only thing keeping pressure contained. If you close it, pressure might build elsewhere. If you open it, you might worsen the release. If you turn the wrong direction, you might discover your own talent for making things worse. So you do the boring thing, the professional thing. You confirm with the outside team. You speak slowly into the radio, describing the valve, the leak, the location, the apparent flow. The incident commander asks you to stand by while they check facility information. This is the part that looks like doing nothing. Doing nothing is often the most life-saving action available. While you wait, you watch the fitting, and you notice something subtle. The dampness is not spreading fast. It is not spraying. It is weeping. A weeping leak suggests low flow, perhaps a failed gasket, perhaps a hairline crack. It might be a liquid under small pressure, or a condensed vapor that drips like sweat. You think about vapor pressure, the tendency of a liquid to become gas. High vapor pressure liquids evaporate eagerly. They are impatient molecules, always trying to escape the crowd. Low vapor pressure liquids are calmer, heavier, more reluctant. They still evaporate, just more slowly, like a threat that prefers long-term plans. You do not know which one this is. You just know it made it to the floor, and it wants to keep going. The commander comes back, and the words are not comforting. They think the line carries a solvent, possibly a ketone, something like acetone or methyl ethyl ketone. Ketones smell sharp, and they evaporate quickly, and they are flammable. They also dissolve certain plastics and strip oils from skin, which is a polite way of saying they can mess you up. The commander tells you not to shut the valve yet. They want the facility maintenance person to confirm what is upstream and downstream. Upstream and downstream are simple words, but they decide whether you get a spray. A pressurized liquid release is a different animal than a drip. A pressurized release can create a jet, and a jet can create mist, and mist can fill a room with flammable atmosphere before anyone finishes a sentence. So you do not touch the valve, you mark it, and you back away slightly, and you keep your body positioned for retreat. The suit is hot now, and you can feel sweat pooling in your lower back. Your heart beats with a steady insistence, not panic, just work. Your gauge is lower, not alarming, but enough to remind you again. Time is a paid subscription. You and your partner make a slow loop, checking for other pathways. You look for floor cracks, for expansion joints, for seams that liquids love. Concrete is not a single slab. It is a puzzle of tiny pores. A spill can soak in, and later, when you think it is gone, it can come back out as vapor. This is called off-gassing, and it feels like haunting. You find a low spot where the sheen is thicker, a shallow puddle catching light. You do not step in it. You do not give it your boot as a sample. You keep your boots clean, not for elegance, but for decontamination later. Every chemical you pick up is a souvenir you do not want. You sweep the meter over the puddle edge. Still steady, you watch your partner's movements, their slow, careful steps, their gloved hands held close. You realize the buddy system is not just companionship, it is a second brain. Inside this suit, your brain is already paying a heat tax. Your partner is there to catch your mistakes, and you are there to catch theirs. A soft crackle comes through the radio, and the safety officer asks for your status. You answer, short and factual. You say your air pressure. You say your heat stress is manageable. You say no new hazards observed. Those words are like stacking bricks in a wall built from calm information. You retreat to the warm zone on instruction, not because you want to, but because procedure does not care about your ego. In the warm zone, an outside technician meets you with a clipboard and a watchful stare. They check your suit for obvious contamination, for wet patches, for anything clinging. They do not touch you with bare hands. They point, they ask, they guide. The warm zone is where you try to make sure the hazard does not travel. Travel is what hazards love. A chemical incident is always trying to expand, socially and physically. You are there to be boring enough that it cannot. You rest for a moment, standing, because sitting in this suit is like sitting in a sauna wearing a backpack. Your breathing sounds loud and steady, and you listen to it like weather. You drink water through a compatible system if you have it. Small sips, because dehydration makes heat stress accelerate. Sweat is fluid leaving you. If you do not replace it, your blood volume drops and your heart works harder. Your body becomes less efficient. Then your thinking gets worse. Then you do something dumb. This is the sequence everyone wants to pretend they are immune to. No one is immune to physiology. You get the next assignment, and it is not glamorous. You are going back in, not to fix the leak yet, but to help identify more precisely what the material is. This is the part where chemistry becomes paperwork again. Labels, safety data sheets, container markings. And yet, it matters, because correct identification decides what kind of glove keeps you whole. You step back into the hot zone, and it feels like returning to a scene that has not moved, but has continued quietly. The puddle is still there, the sheen is still there, the valve still weeps. The air might be fine, or it might be one spark away from regretting your existence. You approach a cabinet on the wall, labeled for chemicals, and you do not open it like a curious child. You open it like it might breathe. Inside are containers, some labeled clearly, some with smudged print, some with the kind of handwriting that should be illegal. You find a container that matches what the commander described, a solvent used for cleaning parts. You note the name and the concentration if you can see it. You read hazard phrases, flammable, irritant, maybe narcotic effects. meaning it can make you dizzy and stupid. Humans love substances that make them dizzy and stupid. Industry just does it by accident. You report the name slowly, and you spell it out if needed. The commander repeats it back because miscommunication is another invisible hazard. A single wrong word can send someone in with the wrong protection. A single wrong assumption can get someone burned, corroded, poisoned, or simply unconscious. Unconscious is not restful here. Unconscious is how you drown in your own tongue. With identification improved, the plan changes. Now, the team can choose proper containment and cleanup materials. Now they can decide whether to ventilate and how. Ventilation sounds simple, but it is a knife. If you ventilate a flammable vapor cloud incorrectly, you can spread it into new spaces. If you ventilate a toxic vapor cloud incorrectly, you can share it with the neighborhood. Sometimes you want to dilute vapors to safe levels. Sometimes you want to contain them and scrub them. In HAZMAT, even fresh air has to be managed. The decision is made to control the leak source with facility maintenance under HAZMAT oversight. That means someone will manipulate the valve, but not until ignition sources are controlled and air is monitored continuously. The team outside begins shutting down non-essential electrical equipment in the affected area. They isolate circuits if possible. They control entry points so no one walks in with a phone charger sparking, or a cigarette, or a brilliant idea. You would be surprised how often the brilliant idea is the ignition source. You and your partner position yourselves near the valve, ready to observe and back out if needed. A maintenance worker arrives in their own protective equipment, and you feel a brief sympathy. They did not plan to spend their night in a plastic suit, listening to their own breath. They brought tools that will not spark, made of brass or other non-ferrous materials. In a flammable atmosphere, even tool choice becomes philosophy. The maintenance worker moves slowly, hands on the valve, pausing. You sweep the meter again, watching for any rise in flammable readings. This is the moment where a drip can become a spray. The valve turns, a fraction. Nothing dramatic happens. Then another fraction. The leak slows, the leak stops, and the scene does not cheer. There is no applause. There is only a quiet reduction in future problems. Congratulations. You have performed the most satisfying act in HAZMAT response, making the source behave. But you are not done, because the spill is still on the floor. The vapors are still in the air. The residues are still in pores and seams. Stopping the leak is like turning off a faucet in a flooded bathroom. You still have the water. Now comes the slow part, the part where most people watching would change the channel. You and your partner begin containment work, laying more absorbent, building a boundary. You create a small corral around the spill, not to trap it forever, but to stop it from spreading. Containment is the art of making the problem smaller. It is not glamorous. It is strategic. You keep your movements minimal. You do not stomp. You do not fan the air. You do not create waves in the puddle, because waves increase surface area, and surface area increases evaporation. Evaporation is your invisible enemy again. You place absorbent pads, flat and thirsty. They darken as they soak, like paper towels in a kitchen, except the kitchen is trying to kill you politely. Some absorbents are designed for hydrocarbons and solvents, and they repel water while taking up oil-based liquids. That property is useful when spills happen in rain or near sprinklers or anywhere water complicates everything. Water complicates everything. Water is a universal solvent in the worst ways. Water dissolves some chemicals, carries them, spreads them. Water also reacts with some chemicals, producing heat, gas, or corrosive solutions. People love to say, just wash it away. In HAZMAT response, washing is an advanced topic, not a reflex. You work from the outside in, collecting the edges first. This reduces the chance of spreading contamination. It is like cleaning glitter. If glitter gave you chemical burns, you pick up a saturated pad with your gloved hand and you place it into a compatible container. Not every waste container is compatible. Some plastics soften in solvents. Some metals corrode in acids. You choose containers like you choose friends by their ability to hold your mess without dissolving. The waste container is labeled because future you deserves not to be surprised. Labeling is respect for the next person. It is also law, but let us pretend it is respect. You continue, pad by pad, sock by sock, making the puddles shrink. As it shrinks, the sheen becomes patchy. You look for that rainbow shimmer some solvents create in thin films. You look for dull areas where absorbent fibers have left faint trails. You keep sampling air because cleanup can stir vapors. A pad pressed down can burp air out of cracks. A sock moved slightly can release trapped vapor pockets. The scene is quiet, but the chemistry is active. Now, while you work, you start to learn what chemicals want, not emotionally. Chemically, a solvent like acetone wants to evaporate. It wants to become vapor because the molecules do not stick to each other strongly. They have weak intermolecular forces, weak attractions. So at room temperature, many have enough energy to escape the liquid surface. That escape is evaporation. The faster they evaporate, the more they cool the remaining liquid, because evaporation steals heat. This is why solvents can feel cold on skin, even as they damage it. Your body senses temperature, not safety. A corrosive chemical, like a strong acid, wants to react. Acids donate protons, which is a polite way of saying they are chemically aggressive in water. They can break bonds in proteins, in membranes, in tissue. A base, like sodium hydroxide, also wants to react, and it can be worse in some ways. Bases can saponify fats. That means they turn the lipids in your skin into soap. It is a wonderfully domestic term for a horrifying process. Soap is fat that has been chemically modified. Your body is partially fat. So a strong base can make you literally dissolve slowly, slickly, without the immediate pain you expect. Pain is sometimes delayed because nerves are not always the first thing to be destroyed. An oxidizer wants electrons. It wants to be reduced, meaning it wants to take electrons from something else. That something else can be metal, paper, cloth, fuel. Oxidizers make fires more intense because they supply the chemical ingredient combustion needs. Combustion is just rapid oxidation, a fast electron exchange with heat and light as the complaint. So when an oxidizer is present, even materials that are normally reluctant to burn can burn like they are showing off. A simple spill can become a reaction if it mixes with the wrong neighbor. The wrong neighbor might be in a drain or on the floor or in the absorbent you chose. This is why responders respect incompatibility. Incompatibility means two substances produce heat, gas, or fire when combined. Some combinations produce toxic gases that behave like invisible knives. Acid plus cyanide can create hydrogen cyanide gas, which stops cellular respiration. It is not choking. It is your cells being unable to use oxygen. Even if oxygen is present, you suffocate at the cellular level. Acid plus sulfide can produce hydrogen sulfide gas, the rotten egg smell that can kill. At low levels, it smells. At higher levels, it paralyzes your olfactory nerves and the smell disappears. That is the worst kind of magic trick. You think you are safe because you cannot smell it, and then you are unconscious. Ammonia plus bleach can make chloramines. Chloramines are lung irritants, and they are not rare because people mix cleaning products like they are cooking. Human beings do not respect labels. They respect vibes. Chemistry does not care about vibes. While you work, you cannot stop thinking about how often hazards are created by good intentions. Someone spilled solvent, tried to clean it with water, spread it. Someone used an incompatible mop bucket with residual bleach, created gas. Someone poured waste down a drain because it was convenient. Convenient is often the true cause of emergency calls. You collect the last saturated pad and the floor looks almost normal again. Almost is not enough. You still have residues. You still have vapors. You still have that valve fitting that leaked and might leak again. So now you shift into detection mode again. Gentle detection, as if you were trying to see a ghost without startling it. You use meters, yes, but you also use your eyes for quiet clues. You look for peeling paint because solvents can soften coatings. You look for discoloration on concrete. You look for softening of rubber, swelling of gaskets. Some solvents cause elastomers to swell, which can worsen leaks. A gasket that was fine yesterday becomes a sponge today. You pass your gloved finger near, not touching, watching for any liquid beading. You check the underside of the pipe where gravity might have hidden a drop. You check the floor corners where liquids gather like dust bunnies. You check behind equipment feet where a small pool can hide. The meter readings stay stable. You feel a small relief, and you do not trust it. Relief can make you sloppy. So you keep the ritual, scan, observe, report. Outside, the team decides on ventilation, a controlled increase in air exchange to reduce vapor concentration. They might use explosion-proof fans designed to minimize spark risk. They might open doors strategically, creating a flow path away from people. They might isolate the area and let time do the rest. Time is often the best ventilation. A solvent evaporates, disperses, and is removed by air exchange. But you cannot always wait, because buildings are used by humans who demand normal life. Humans demand normal life even when the universe is actively dissolving their infrastructure. The commander asks you to withdraw because your work period is nearing its limit. This is the heat and air management again. Leaving early is success. You retreat with your partner, slow, careful, stepping exactly where you stepped before. You avoid dragging contamination outward. You avoid brushing against door frames because door frames touch everyone. You cross into the warm zone and you stop. The warm zone smells like wet rubber, disinfectant, and human effort pretending it is fine. Your boots squeak on a tarp that exists purely to catch what you cannot see. A technician raises a gloved hand, and you hold still, because stillness is part of the procedure. They scan you with a meter again, not because they mistrust you, but because they mistrust everything. Your suit is treated like it is painted with invisible ink, not magical ink, just chemical residue that does not announce itself. You stand with your arms slightly out like an awkward scarecrow while they look for wet patches. They look for smears where a glove brushed a valve or a knee touched a stained floor. The outside of your suit is the only part that saw the hazard. The inside of your suit is the only part you care about keeping human. So now the ritual shifts. The mission is no longer to stop a leak. The mission is to stop the leak from following you home in the form of a fingerprint. This is the quiet reason HAZMAT has a warm zone at all. It is not dramatic containment. It is social containment. It is how you prevent one incident from turning into 100 small exposures. A hose line appears, and it is not a fire hose fantasy. It is a controlled stream, low pressure, aimed carefully, like watering a plant you resent. Depending on the chemical, the rinse might be plain water, or water with a mild soap, or a specific neutralizing solution. Neutralization sounds satisfying, like canceling a villain. In reality, neutralization is a reaction, and reactions make heat. If you neutralize the wrong thing the wrong way, you get steam, splatter, and regret. So most of the time, decontamination is not chemistry theater. It is dilution. It is physically removing molecules from surfaces and carrying them into a controlled waste stream. A brush touches your suit, gentle, not scrubbing hard. Hard scrubbing can grind contamination into seams or aerosolize droplets into the air. You are learning again that force is rarely the solution. Precision is. The wash starts at your head and shoulders because gravity will bring everything down anyway. They rinse your hood, your visor, your chest, your arms, then your legs, then your boots. You feel cool water on the outside, and inside you feel only the suit's trapped heat. It is an odd sensation, like being rained on in a dream you cannot wake from. The technician speaks in short phrases because long speeches do not survive through a mask. Turn slowly, arms up, foot forward, stop. You obey because obedience is how you stay unpoisoned. The decon line is a choreography where everyone is tired and everyone pretends not to be. They rinse your gloves last because gloves touch everything, and everything is suspicious now. Then comes the part that looks simple and is not simple at all. Doffing the suit, taking it off without touching the outside with your inside. It sounds like a children's puzzle until you realize the consequence is a chemical on your wrist. A technician steps in close, and you are suddenly aware of how near your visor is to theirs. They are protected too, but not always with the same level of suit as you. HAZMAT teams choose protection like choosing insulation for a house. Too little, and you freeze. Too much, and you overheat and make mistakes. So the decon staff often wear lighter gear, and they rely on process to stay safe. The first thing to go is usually gross contamination, if any is visible. Then outer tape is cut, not ripped, because ripping snaps droplets into motion. Your arms stay out, and they peel tape away like they are removing a bandage from the world's least cooperative patient. Then the outer gloves might come off, depending on the layering. Glove removal is its own miniature science. Pinch, peel, roll, keep the contaminated exterior folded inward. It is the same logic as taking off a muddy jacket without smearing mud on your shirt. Except the mud can dissolve you or simply sneak into a cut you did not know you had. Now, the zipper. The zipper is a seam, and seams are where the universe tries to get in. The technician pulls it down slowly, while another holds the suit material away from your underlayers. You do not reach in with your own hands unless instructed, because your hands are not objective. Your hands are impatient, and impatience is contagious. The suit peels down off your shoulders, and trapped heat escapes in a faint rush. It feels like opening an oven door, except the oven is you. Your underclothes are damp, your skin is slick with sweat, and your hair is flattened in the way only serious discomfort can manage. The mask is still on. The mask stays on until the suit is low enough that you will not drag your face through contamination. Then, finally, they release the straps. The mask lifts, and ordinary air hits your nose like a soft shock. Even if the air is just a parking lot at night, it feels rich. Humans are embarrassingly grateful for boring air. You take a breath that is not filtered through a regulator, and it feels like cheating. Your mouth tastes faintly metallic, or maybe that is just adrenaline residue. You are guided to a clean area, and you wash your hands again anyway, because hands are the diplomats of the body. They touch everything, and then they touch your face when you are not thinking. This is how contamination travels, by the oldest human habit of rubbing an eye. You might expect decontamination to be fast, like ripping off a costume, but fast is how you smear hazard onto skin, or into a hair, or into a sleeve cuff. Slow is how you avoid spending the next week wondering if your headache is stress or exposure. And now, with the suit off, the world reveals a quieter threat. Not the solvent on the floor, not the vapors that might have been there, the threat of what you brought out on you and what you might bring home on you if you get sloppy. HAZMAT calls this secondary contamination. It is the hazards spreading by contact, like gossip with teeth. Hospitals know this problem well. A patient arrives with pesticide on their clothes, and suddenly the emergency room smells wrong. A worker arrives after an industrial accident, and the nurse gets burned handling a shoe. The original incident becomes a chain. So decon is boring on purpose. It is designed to be slower than your ego. If you are impatient, the system wins and you lose. While you cool down, someone bags the suit. The bag is labeled, sealed, and treated as waste or evidence depending on the situation. Waste is not thrown away casually in this world. Waste is chemistry in a new container, still obedient only to physics. The pads you used, the absorbent socks, the gloves, the rinse water, all of it becomes managed material. It is weighed, documented, and stored for disposal by licensed processes. That is the unromantic truth. A big part of HAZMAT response is paperwork that prevents tomorrow's disaster. Your body keeps catching up to what you just did. Your heart rate comes down slowly, like a machine winding down after a long shift. Your hands tremble slightly, not with fear, but with the aftermath of sustained effort. Adrenaline is not a switch. It is a bath you soak in. It drains gradually, and as it drains, you feel tired in layers. First, physical tiredness, heavy legs, warm skin, thirst. Then, mental tiredness, the strange emptiness after intense focus. This is the part no one sees on the news. The news likes action, not recovery. But your nervous system has its own cleanup phase, and it takes time. You sit on a folding chair, and it feels like luxury furniture. Someone hands you water, and it tastes like the concept of survival. You drink, and you feel your body accept it with quiet gratitude. You might have been inside the hot zone for a short time, but the heat load lingers. Your core temperature takes time to normalize. Your blood vessels adjust. Your sweat glands slow down reluctantly, like workers asked to stop mid-shift. And the whole time, your mind replays the scene. Did you step too close to the puddle? Did your glove brush the valve? Did you touch your mask? This replay is not paranoia. It is learning. Human brains evolve to remember near misses because near misses are free lessons. Free in the sense that you survived them, not free in the sense that you will pay attention later. While you rest, the outside team continues. HAZMAT response is a relay, not a sprint. One team goes in, another team prepares, a third manages decon, a fourth coordinates information. You are never the only person doing the work. And that is the point. The buddy system extends beyond pairs and suits. It is an entire scene built to keep one person's mistake from becoming a tragedy. You listen to radio traffic. Quieter now, a steady stream of status updates. Air monitoring continues. Ventilation is adjusted. Waste containers are sealed. A final inspection of the leak point is planned, and a repair schedule is discussed. Because stopping a leak tonight does not mean the system will not leak again next week. Chemistry does not respect the end of a shift. It will keep doing what it does, patiently, until someone changes the conditions. This is where the job becomes less like an emergency and more like maintenance of reality. A valve fitting is replaced. A gasket is upgraded to a more compatible material. A line is depressurized and tested. The cause is documented because causes are what keep you from repeating scenes. You might expect the most important part to be the dramatic entry, but often the most important part is what happens after. Confirming that the hazard is truly contained. Confirming that the area is safe to reoccupy. Confirming that no one is quietly being poisoned in the next room by vapors you forgot could travel. Air monitoring after the cleanup is a kind of epilogue, but not an ending. You sample near the floor, near the ceiling, in corners, near doors, near vents, because air is not fair. It can hold a pocket of vapor behind a machine for hours. It can trap a heavy gas in a low trench that looks harmless. It can move through ductwork like a rumor through an office. If the chemical was a solvent, you might also worry about off-gassing from porous surfaces, concrete, wood, some plastics. They can absorb and later release, like a sponge that refuses to forget. So responders sometimes use fans not just to clear air, but to keep air moving long enough for surfaces to give up what they took. If the incident is indoors, ventilation choices matter. Positive pressure ventilation can push air into a space and force contaminants out. Negative pressure ventilation can pull air out and keep contaminants from spreading to clean areas. Hospitals use negative pressure rooms for infectious patients because microbes also travel on air. Different hazard, same geometry. Flow paths are designed, doors are cracked or sealed, filters are used if needed. High-efficiency filters can capture particles, but gases require different treatment. Activated carbon can absorb some vapors. Scrubbers can neutralize certain gases by passing them through reactive media. But again, field response is often about being practical. Sometimes you ventilate and monitor until readings are low enough to call it stable. You do not chase perfect. You chase safe enough that normal life does not become a silent experiment. You hear someone mention permissible exposure limits, the occupational thresholds for certain chemicals. These are not magic safety lines. They are negotiated compromises between biology, economics, and law. A limit might be set for an 8-hour workday, assuming healthy adults, assuming typical conditions. It does not account for the asthmatic, the pregnant, the child, the person with a hidden lung problem. So hazmat teams often aim below limits because limits are not kindness. Limits are bureaucracy with a calculator. You are reminded again that smell is not a reliable guide. Some solvents have strong odor at low levels, acting like accidental alarms. Others are dangerous at levels below odor detection. And some chemicals fatigue your sense of smell, meaning the odor fades as your exposure increases. Your nose is not a meter. Your nose is a fragile piece of wet meat with opinions. As the scene stabilizes, you get a quiet moment to think about what you just did from a scientific angle. Hazmat work is applied chemistry, but it is also applied human limitation. Everything is designed around the truth that you are not built for this environment. You need barriers, air tanks, buddy checks, time limits. You need to externalize caution into checklists because your brain is unreliable under stress. This is why the calm choreography matters. It is not a vibe. It is the engineering of human behavior. If you follow steps, you reduce variance. If you reduce variance, you reduce surprises. And in hazardous materials response, surprises are where injuries live. A responder nearby is logging entry times and exit times. They record cylinder pressures. They record who went in, what they did, and what they observed. This is not obsessive. This is memory that cannot forget. After a scene, people argue about what happened. Logs do not argue. They simply exist. If someone later develops symptoms, you want exposure timelines. If a regulator asks for documentation, you want proof of procedures. If a company needs to fix a system, you want specifics. The boring administrative layer is what keeps the job from being purely reactive. And now, since your first entry was reconnaissance and containment, your next assignment might be something even less glamorous. Tool decontamination. Everything that went in comes out, and everything that comes out is suspect. Tools are wiped, rinsed, sometimes soaked, depending on compatibility. Some tools are considered disposable if contamination is too risky, because cleaning a tool is not worth contaminating a person. You watch someone clean the handle of a wrench with the same care a surgeon uses on an instrument. Because small residues on a handle become hand residues, then face residues, then mouth residues. That is the entire tragedy in miniature. The scene continues to shrink, conceptually and physically. Perimeter tape moves inward. Access control relaxes slightly, but not completely. You still keep ignition sources controlled. because vapors can linger. You still monitor because meters sometimes catch late surprises. And you still treat the drain as suspicious until you are sure nothing went down it. If anything did, you might need to notify utilities, sewer authorities. Chemicals in wastewater systems are their own genre of trouble. Some treatment plants rely on bacteria to digest waste. Certain chemicals kill those bacteria, and then the plant stops working properly. Some chemicals create flammable atmospheres in confined spaces. Some create toxic gases in manholes. It is all connected, and connection is what hazards exploit. Speaking of connection, you start thinking about what happens if this had been a different chemical, because tonight was a solvent, something familiar and industrial. But hazmat responders also meet substances that do not behave like a simple spill. They meet oxidizers that can ignite organic material. They meet acids that fume and eat concrete. They meet cryogenic liquids that freeze flesh and embrittle metal. They meet compressed gases that are toxic, flammable, or simply eager to displace oxygen. They meet pesticides, industrial cleaners, lab reagents, and sometimes things that are not supposed to exist outside a controlled cabinet. Your mind drifts, not into fantasy, but into the catalog of how chemistry can hurt you. And you realize something quietly unsettling. Most of these substances are not rare. They are normal tools of modern life. The extraordinary part is not the chemical. The extraordinary part is that you normally do not notice them. A warehouse is full of solvents. A farm is full of pesticides and fertilizers. A hospital is full of sterilants and drugs that can be dangerous in bulk. A pool supply store is full of chlorine donors and acids. A refrigeration system might hold ammonia. A water treatment facility might hold chlorine gas or sodium hypochlorite or other disinfectants. You sleep in a world that runs on controlled reactivity. Most days, the control holds. On nights like this, you see the cracks. The team leader checks on you again. They ask about your condition because heat stress has a delayed edge. You might feel fine while adrenaline is high, and then feel awful later. They look for confusion, clumsiness, headache, nausea. These symptoms are boring words for a body overheating. They also look for signs of chemical exposure, eye irritation, coughing, unusual skin redness. It is never just one hazard. Heat and chemical and stress stack together like weights. You notice how responders talk about these risks without drama, because drama is wasted energy. Wasted energy becomes heat, and heat is the enemy inside the suit. Eventually, another entry team prepares, perhaps to collect remaining residue or to verify the repair. You watch them suit up, and you recognize the same slow armor ritual. Gloves, tape, mask, seal check, buddy inspection. It looks repetitive because it is. Repetition is a safety feature. Your brain likes novelty, but novelty gets you injured. The next team goes in, and you stay out, cooling down, drinking water, waiting for your own second entry or for the scene to close. This waiting is part of HAZMAT too. The public sees waiting as indecision. In reality, waiting is caution given a chair. While you wait, you think about how detection tools shape behavior. Meters have alarms, and alarms change minds quickly. A flammable gas meter might beep faster as concentrations rise. Humans respond to rising beeps like animals respond to growls. It triggers urgency, but urgency is not always helpful, so responders train to treat alarms as data. not as panic buttons. You might also use colorimetric tubes, little glass tubes with chemicals inside that change color when a specific gas is drawn through. They are oddly old-fashioned, like chemistry from a classroom, but they work, and they are specific when meters are broad. A hand pump draws a measured volume of air through the tube. The stain length indicates concentration. It is simple, mechanical, and satisfying, like reading a thermometer. Test strips exist too, for acids, bases, oxidizers, certain ions. You touch a strip to a wet surface and watch color shift. A small, quiet transformation that tells you something about what is trying to eat your building. But you always remember that field tests have limits. They can be fooled by mixtures. They can be thrown off by temperature. They can be misread under poor lighting. So you bring your own light, a headlamp with a beam that can be aimed, softened, and trusted. You learn quickly that good lighting is a safety device, not a convenience. A dull yellow streetlight can make a clear liquid look like dry concrete. A blinking emergency strobe can make a color change on a test strip look like a hallucination. So you create your own small sun, and you point it where the chemistry might hide. You also learn to cross-check. You do not trust one tube, one strip, 1 meter, one glance. You compare readings, and you compare locations, and you compare time. If a number rises when you crouch, you respect the layer near the floor. If a number rises near a vent, you respect the building's lungs. If a number stays low but your eyes see a shimmering film, you respect the limits of the sensor, because sensors are picky. A combustible gas meter might be great for hydrocarbons and not great for certain solvents. A photoionization detector, if you have one, might respond to many organic vapors, but not all. It reads broad categories, not names. It tells you something is here that can be ionized by ultraviolet light. That is like saying there is a person in the room who has opinions. Useful, but not specific. And sometimes the sensor is wrong in a way that feels personal. Humidity can interfere. Cold can slow reactions inside a tube. A dirty filter can starve the pump and make the air sample lie. So you treat every reading like a witness statement. Important, incomplete, potentially dramatic. Your job is to make the scene boring anyway. You watch the next entry team bring in more absorbent, and you notice how they walk. They walk like people carrying soup. No sudden turns, no quick stops, no splashing. A hazmat scene trains your body into gentleness. Even your footsteps become a form of containment. They lay pads, and they collect pads, and the waste containers become a small tower of managed trouble. Every bag is sealed. Every bag is labeled. And you can feel the strange relief of putting invisible risk into visible containers. A human mind loves a container. A container means a boundary. A boundary means you can stop imagining the worst. But boundaries are only as good as their seams. You watch someone tape the lid on a drumliner and you think about diffusion. Molecules do not respect your feeling of closure. If a vapor can permeate plastic, it will. If a solvent can soften a bag, it will. So waste packaging is its own quiet chemistry. Compatibility charts matter. Temperature matters. Time matters. This is why disposal is not just tossing it out. Disposal is a controlled handoff to a system designed for ugly materials. Incineration for some organics, turning molecules into simpler gases under controlled heat. Neutralization for certain acids or bases, done carefully in facilities that plan for heat. Stabilization, mixing waste with binders so it cannot leach. Each method is a compromise between physics and regulation. And regulation, when it is done well, is just society admitting chemistry exists. Eventually, the commander calls it stable enough for the next stage, not safe forever, not magically pure, just stable enough to transition from emergency mode into cleanup mode. The perimeter shrinks again, the cold zone feels closer, people start talking in slightly longer sentences. That is one of the earliest signs a scene is calming down. When language has room to stretch, danger has stopped shouting. But now comes the part that decides whether the danger follows you home. Decontamination does not end with suits. It continues with tools, paperwork, and your own nervous system. You watch someone wipe down a meter with approved wipes. Electronics cannot be hosed like a boot, so you use careful swabs and you avoid pushing liquid into buttons and seams. You remove batteries sometimes to prevent corrosion. You bag equipment if there is any doubt, because doubt is treated as real until proven otherwise. The meter that saved you can also betray you later if its sensor is contaminated. Some sensors can be poisoned by certain chemicals, meaning they lose sensitivity. That is an annoying word, poisoned, because it is true in a technical sense. A catalyst surface can be fouled, a detector lamp can be coated, a filter can be saturated, so instruments get bump tested, calibrated, checked against known concentrations. This is more boredom, more ritual, more safety. Then you meet the last part of the scene that still feels sharp. Medical monitoring. Not because you think you are sick, because you respect delayed effects. A responder checks your pulse. They check your temperature. They ask about headache, dizziness, nausea, tingling. You answer, and you listen to your own answers. Heat stress makes people minimize. Exposure anxiety makes people exaggerate. So you try to be factual, even about your own feelings. You realize how strange that is, treating your body like a meter. But that is what the job demands, treating yourself as a system with limits. If your temperature is high, you cool. If your pulse is too fast, you rest. If you have cough or eye irritation, you document and evaluate. It is not dramatic care. It is preventative maintenance on a human. And while all this happens, you start thinking about what this job does to the brain. Not in the heroic way, in the quiet, biological way. Your nervous system is an animal system. It is built to notice threats and to keep noticing them, even after the threat is gone. The first phase is simple. Your sympathetic nervous system, the fight or flight wiring, turns on. Heart rate rises. Breathing gets shallower. Attention narrows. Your hearing becomes selective, focusing on radio, on alarms, on voices. Your skin feels every shift in temperature. That system is helpful. For a while, it makes you fast. It makes you focused. It also makes you spend air faster, sweat faster, and think in shorter loops, which is why HAZMAT culture prizes calm. Calm is not personality. Calm is a tactic for reducing your own biological noise. Now, as the scene settles, your body tries to switch back. The parasympathetic system begins reclaiming territory. Heart rate falls. Breathing deepens. Muscles unclench. But the change is not smooth. Adrenaline and noradrenaline do not leave politely. Cortisol does not vanish on command. They fade like a long echo. So you get that strange, after feeling, a slight tremor in your hands, a light headache behind the eyes, a hollow fatigue, like your brain used up its bright fuel. You might also feel oddly cold. After sweating in the suit, cooling off can overshoot. Your skin is damp. Air touches it. Evaporation finally works, and it steals heat fast. So you shiver in a way that feels unfair. Your body spent an hour trying to get rid of heat. Now it complains about losing it. Congratulations. You are a mammal. This is why post-incident rehab exists. Not just to be nice, to prevent people from making mistakes on the next call. Because tired brains cut corners. And corners are where contamination hides. The most dangerous point in many responses is not the hot zone. It is the moment after, when the brain says, it is over. When hands move faster, when gloves come off too soon, when someone scratches their face without thinking. So the process keeps going. Even when everyone wants it to be done, you check your hands again. You wash again. You change clothes if needed. You put contaminated garments into bags that will be handled like waste. You wipe down your phone if your phone came near the scene, because phones are magnets for everything. They touch gloves, they touch faces, they travel into cars and homes and beds. Secondary contamination is rarely a dramatic poison. It is usually a small, avoidable exposure, a rash that appears later, a smell that shows up in your car and refuses to leave, a headache that makes you wonder, was that stress or something else? So you become almost absurdly cautious about mundane objects, keys, pens, water bottles, door handles, your own steering wheel, because the HAZMAT mindset, once it clicks on, does not fully click off, not right away. And you start to understand why responders can seem a little distant after a call. They are not emotionally distant. They are still running checklists inside their heads. Did I doff correctly? Did I touch the outside of the glove? Did I wash the back of my neck? Did my partner's tape catch on the zipper? You replay and replay and replay. This replay is annoying, but it is also adaptive. It is how the brain consolidates a procedure under stress. It is you building muscle memory out of a near miss you did not even notice. The job is learning by repetition and by small scares. Most scenes, when done well, do not create trauma stories. They create boring stories. We stopped a leak. We contained a spill. We ventilated. We monitored. We decontaminated. We went home. Boring is success. Boring is the absence of fire. Boring is a neighborhood that never knows how close it was to a very different night. And yet, your body still paid. It paid in heat. It paid in effort. It paid in attention. Attention is a resource. Spend it long enough, and it leaves you tired in a specific way, like your thoughts have sand in them. This is why crews rotate. This is why the command structure exists. This is why you do not send one person to do everything, because humans are not built to be perfect for long periods. We are built to be good enough and to rest. You sit again and you listen to the radio as if it is weather. A final air monitoring pass is completed. Readings stay low. The ventilation plan remains in place. A gentle exchange of air. The facility is advised to keep doors open in certain areas and to avoid ignition sources until fully cleared. A repair crew will return in daylight when fatigue is not running the operation. Daylight changes everything, not the chemistry, the human part. In daylight, people make fewer sleepy mistakes. In daylight, you can see the sheen you missed at midnight. In daylight, labels are readable and color is honest. But for now, the night shift does what night shifts always do. It stabilizes the world enough that other people can pretend reality is safe. And as you start to pack equipment, the scientific part of your mind keeps wondering, because this solvent incident was manageable. It had rules you recognized. It had an odor that was familiar to industry. It did not produce immediate violent reactions. But the same procedures apply to worse things. And it is hard not to imagine them. A chlorine release, for example. In a water treatment facility, chlorine is greenish-yellow when dense enough, but you do not want to rely on that. It is heavier than air, and it hugs the ground. It reacts with moisture in your eyes and lungs, forming acids, hydrochloric acid and hypochlorous acid, which sounds clinical but feels like burning. The gas does not need to be hot to injure. It just needs to be reactive. And it is. In a chlorine incident, distance matters even more. Wind matters even more. Elevation matters because it sinks into low areas. People who run downhill into a ditch can run into higher concentrations. It is cruel in that specific way, punishing instinct. Or take anhydrous ammonia, common in refrigeration and agriculture. Ammonia is lighter than air, so it can rise, but it also dissolves in water. And your body is mostly water, it causes chemical burns, and it has a sharp odor at low concentrations, which is a rare mercy. But high levels can overwhelm quickly. It can make your eyes clamp shut, your throat spasm, your lungs panic. A person can become incapacitated simply because they cannot keep their eyes open long enough to escape. And in high concentration, it can be flammable too, which feels unnecessary, but chemistry does not care what feels necessary. Even carbon dioxide, the boring gas people talk about in climate discussions, becomes lethal in the wrong place. In confined spaces, it displaces oxygen. Your body does not detect oxygen directly. It detects carbon dioxide buildup. So, in an oxygen-poor environment, you might not feel urgent air hunger right away. You can become confused, weak, and then unconscious. Confined space hazards and hazmat hazards overlap like that. Different labels, same biology. That is one of the reasons hazmat responders treat unknown atmospheres with such suspicion, because the atmosphere can kill without drama. A person walks into a tank, collapses, another person goes in to rescue, collapses, a third person goes in, collapses. It is a chain made of good intentions and bad air. So the first rescue is often not a person. It is ventilation. It is air monitoring. It is a rope. It is a tripod and a winch. It is a procedure that prevents you from adding bodies to the scene. This is the part that can feel cold. Not emotionally cold, just strategically cold. You do not rush in, because rushing in is how you create multiple victims. Your job is to keep the incident count from multiplying, and you start to see the deeper philosophy. HAZMAT response is not about winning against chemicals. It is about refusing to play their game. Chemicals want contact. They want mixing. They want time with your tissues. They want oxygen, or they want electrons, or they want water. They want simple things, and they get them if you let them. So you do not let them. You put plastic and rubber and procedure between you and their preferences. You keep your skin unoffered. You keep your lungs on a separate supply. You keep your hands from touching, even when your brain wants to. And when you must touch, you do it with layers and tools and time limits. It is very human, in a way. You build rituals because you are fragile. Ritual is how fragile creatures survive in worlds that do not care. As the call winds down, people talk about documentation again. Who notified the environmental agency? Who contacted the facility manager? Who logged the waste? Who recorded the meter readings? Those numbers and notes matter later. If someone reports symptoms, you want a record. If the facility has a repeat leak, you want a pattern. If a regulator investigates, you want evidence of control. And evidence is just memory made durable. It is boring, and it is protective. You collect your gear into cases. Each case has compartments, and each compartment has a purpose. That is another small psychological trick. Order reduces anxiety. Order reduces mistakes. You wipe handles again because handles get touched, and touch is how things travel. You remove tape scraps and dispose of them properly. Small pieces of tape can carry residue. The smallest objects are often the most dangerous because they slip through attention. Your partner looks tired, not melodramatically tired, just the slow tired of doing everything carefully. Carefulness is labor. It is cognitive labor, and it uses energy in a way people do not respect. A person can be exhausted without lifting heavy things simply by making 100 correct decisions in a row. That is what the job asks. 100 correct decisions, or at least decisions made slowly enough to be checked. The team leader debriefs, briefly, what went well, what needs improvement, any equipment issues, any communication problems. Debriefing is where the scene becomes a lesson rather than just an event. It is also where small frustrations can surface. A radio that cut out, a label that was unreadable, a delay in getting facility information. Those are not dramatic failures, but they are the kind that can matter next time. So people talk about them now, while memory is fresh. Then the scene is handed back. Back to the facility. Back to the night security guard. Back to the silent pipes and the unremarkable walls. And you feel that odd shift. You have been in a space where everything mattered, where a footstep had consequences. Now you return to a world where people open doors without thinking, where they pick things up with bare hands, where they rub their eyes, where they breathe casually. That casual breathing feels almost obscene for a moment because you just spent hours treating air like a suspect substance. You load into a vehicle and the seat feels too soft. Your body is still half in the suit. Mentally, you notice the smell of the cab, plastic, coffee, detergent, all the normal chemicals of daily life. You realize hazmat work does not take you into an alien universe. It takes you into the real universe without the comforting filter of ignorance. The same solvent that spilled tonight might be in a garage cabinet somewhere. The same acids might be under a sink. The same compressed gases might be in a store, in small cylinders, waiting to be used. And the difference between safe and unsafe is usually context, containment, and attention. A sealed bottle is boring. A cracked bottle is a call-out. A closed valve is boring. A weeping valve is an incident. A labeled container is boring. An unlabeled container is a threat, even if it is harmless. Because the threat is not always the chemical itself. The threat is the unknown. Unknown forces you to assume worst case. It costs time. It costs equipment. It costs sleep. You get back to the station or to the staging area, and the quiet continues. Gear is restocked. Air cylinders are refilled or swapped and sent for inspection. Regulators are checked. Masks are cleaned, disinfected, dried. Face pieces are personal equipment for a reason. Skin oils can degrade seals over time. Dirt in a gasket can cause a leak. A leak is not always dramatic. A leak is sometimes just a faint smell inside a mask, and then a headache later. So cleaning is treated like safety, not housekeeping. You think about the simple physics of a seal, a soft silicone or rubber edge pressed against human skin. Human skin is irregular. It has pores, it has hair, it sweats, it moves when you speak, and yet you ask that seal to be reliable. So you shave facial hair for certain masks. You tighten straps to specific tensions. Too loose and it leaks. Too tight and it hurts, and pain becomes distraction. Everything is compromise. Everything is designed around imperfect humans. And now, with the work done, your body finally lets itself feel what it postponed. Thirst first, then hunger, then the deep weight behind the eyes, then the mild soreness in small muscles from moving carefully in awkward gear. Your shoulders remember the tank. Your hips remember the stiff suit. Even your hands remember gripping tools with thick gloves. It is a kind of soreness that feels absurd given how calm the scene looked. But that is the hidden cost. Looking calm is work. Looking calm is controlling your breathing, controlling your movements, controlling your thoughts. It is not natural. It is trained, and training is just rehearsed survival. Some responders develop their own small mental habits, not rituals of superstition, rituals of focus, counting steps, repeating checklists under the breath, touching certain equipment points in the same order. These habits are not quirks. They are ways to reduce cognitive load. If you make a sequence automatic, you free your mind for the unexpected. And the unexpected is always waiting, quietly. Because the universe is inventive. A container fails in a way you have not seen. A chemical is misidentified. A spill reaches a hidden sump. A ventilation fan changes the plume direction. So you keep your mind ready, even while you try to relax. This is one of the strange long-term effects. HAZMAT work trains hyper-awareness in bursts, and the brain does not always appreciate being turned on and off like a light. Some people sleep fine anyway.